Hi everyone, I'm Harish Trivedi from Stony Brook University, and today I'll talk about AppWorld, a controllable world of apps and people for benchmarking interactive coding agents. This is joint work with collaborators from Stony Brook University, Allen Institute for AI, and Saarland University. Our day-to-day digital lives involve doing various tasks on our app accounts, such as returning an Amazon order and buying a replacement, and sending owed money to friends on Venmo. Can AI agents do such tasks on our behalf? To make it more concrete, consider a running example. Play my Spotify playlist with enough songs for the workout today. My workout plan is in simple note. One way models can tackle such tasks is by writing code that calls apps APIs. But since the tasks are complex, this code has to be rich and has to be written interactively. Let me explain it by showing how an ideal agent could tackle our running example. First, it has to find the user's workout plan. For this, it gets the user's simple note credentials, logs in, searches for workout related notes, and finds one, all via writing a code snippet making appropriate API calls to the simple note app. Next, it has to figure out the workout duration from the note. This it cannot do within the same code snippet even with the perfect knowledge of API's input and output structure. This is because how to infer the duration for today depends on how the node's content is structured. So it interacts with the environment by printing the note and seeing its content. The agent discovers the workout plan in the node is structured day-wise as opposed to date-wise, month-wise, or any other way. So it prints the current day again via environment interaction. Finding it's Tuesday, it infers a 45-minute workout and searches for a playlist with enough songs for that duration. This search involves writing rich code with various programming constructs like loops, conditionals, arithmetic, and so on. So in summary, we saw that a seemingly simple day-to-day task can be quite complex, and it has two key requirements. It necessitates environment interaction to write the next code snippet, and the code itself is rich with various programming constructs. So the key question is, how can we develop and benchmark such rich and interactive coding agents for complex digital tasks in a rigorous and reproducible manner? For this, we argue in the paper, we need three ingredients: a rich and reproducible execution environment of many API operable apps, a benchmark of complex tasks requiring API calls with rich and interactive coding, and a robust and programmatic evaluation framework for checking goal completion. There are many recent tool use benchmarks, but they do not support these three requirements. To bridge this gap, we introduce AppWorld, which constitutes AppWorld Engine, Benchmark, and Evaluation. Let's begin with Engine. AppWorld Engine has implementation of many day-to-day apps in a local backend of APIs and databases. It provides full control over its database state, which enables challenging task construction and robust evaluation. These apps are also populated with simulated digital activities of people on their app accounts. This provides a foundation of a realistic environment to build tasks on top of. Our app implementations are high-fidelity simulators of the corresponding apps. They span over 60,000 lines of code, have 457 APIs with detailed documentation, and 100+ database tables. These apps are also populated with realistic personal and interpersonal digital activities of fictitious people, related via various relationships like roommate and manager, allowing for realistic tasks like splitting bills with roommates. AppWorld Benchmark builds tasks on top of the simulated world. We start with carefully crafted day-to-day scenarios which naturally require rich and interactive coding. Here the scenario is an ungrounded blueprint for the task. For each scenario, we write a generated program to ground it into three varied tasks. Each task is defined by three things: the instruction, the supervisor, who is the person in the world assigning the task, and the world state, which is the database state and current time in the world. For each task, we also write solution code and evaluation tests that programmatically verify the task solvability. Note that we have written these codes individually for every task scenario. To complete the task, the agent is given the instruction, supervisor's credentials, all API documentation, and an interactive coding shell with an API client. Our generator codes for each scenario is carefully written to ensure 4 key task properties. Namely, the task is well defined, meaning it is solvable. It has distractors and hurdles, meaning it necessitates thorough reasoning and avoids solvability via shortcuts. And it has task variations to assess reliability across different instruction and state variations. For example, to make sure there are distractors in the Spotify task, we ensure the supervisor has several playlists and different workout duration for different days, and only one playlist qualifies for the today's workout. Note that such careful task construction is possible because AppWorld engine gives full control over its initial state. Check out other properties in the paper. Based on our solutions, we can see that tasks are challenging, requiring multiple apps and many APIs and lines of code, even when we have perfect knowledge of APIs. In practice, agents require a lot more code and API calls as they learn by interaction and exploration. Overall, we have 750 such tasks, with the test challenge split as the main test set, which includes higher complexity tasks and tests generalization to unseen apps. We also have test normal, which has the same distribution as train and dev splits. Next, we need a robust way to evaluate agents. Agents can solve such tasks in many ways. For example, they can download Amazon receipt from its APIs or its email confirmation, and both are valid. And agents can also cause collateral damage in many ways. For example, deleting emails when asked for placing an Amazon order. So comparison to a reference solution cannot be used. Therefore, AppWorld uses a state and execution based approach. In particular, we compare the world states before the agent starts and after it ends. We compute the difference in its underlying database states to obtain cumulative changes the agent has made to the tables, rows, and columns. We then check that these changes include all expected and no unexpected changes for the task, as enumerated by us. And the check itself is done via programmatic unit tests. We have two evaluation metrics: task goal completion, which checks that all tests in a task pass, and scenario goal completion, which checks that all tests for all 3 tasks in a scenario pass. Alright, so how do agents perform? We benchmark open and close LLMs with various kinds of few-shot prompting methods like React, planning and execution, repeated parallel function calling, and full code generation with reflection and retrials. Here the plot shows each LLM's task goal completion on test normal when paired with the highest scoring prompting method. Even the best LLM GPT-4o gets under 50 points. The scores significantly drop when we look at scenario goal completion. This shows that agents are not reliable and fail to complete tasks under slightly different conditions. Furthermore, all scores significantly drop on test challenge, which is our main test set. For example, GPT-4o only gets 13% in scenario goal completion. The scores also drastically drop for all methods as task difficulty increases. For example, as per our hand label difficulty levels, and as per the number of APIs and lines of code according to our solutions. Finally, we find that agents make common errors such as assuming information instead of finding it, hallucinating API input and output fields, and making various kinds of coding and common sense errors. In summary, we have introduced AppWorld, which was born out of a significant engineering effort by our team, writing over 100,000 lines of code, delivering a high-quality, realistic environment, complex tasks, and robust programmatic evaluation for benchmarking interactive coding agents. We are excited for the opportunities that AppWorld opens for the future work in building better agents, creating new agent benchmarks, and studying agents in a simulated environment. For example, using self-exploration for generating training data, adding UI support for multimodal agents, and studying safety and privacy risks of personal agents. I'm happy to discuss this more offline. So visit our website for Data Explorer, Playground, Leaderboard, and a lot more. We have made AppWorld super easy to use and fast. You can pip install AppWorld's Python package and start building and testing your agents. If you have an agent, the code on the left is all you need to run and evaluate it on AppWorld. Thank you.